Hi there, Science 9 and Science 10, also Chemistry 11. Mostly this is a lesson for Science 9, filling in some lecture notes, but Science 9, you might find this useful, interesting. Chemistry 11, I have a challenge problem for you at the end of this lesson, so we'll get started. So again, Science 10 students, just be with your package here. We're going to finish this lesson here. That's lesson 1.2. We started that before, got through the first page. I talked to you about covalent compounds and ionic compounds. What we're going to look at today are different kinds of events that could happen in chemical reactions with compounds and with elements. The notes here describe three situations. One situation is maybe the simplest of types of chemical reactions where two different elements combine to make one compound. Another is a case where you can have a compound that instead breaks apart. It's really the opposite direction of that same reaction. And then the more complicated reactions, which really are the majority of chemical reactions, involve compounds and elements either breaking apart or breaking apart and forming new bonds. We're going to look at some examples of those chemical reactions today. In fact, it's going to be really three parts of this. I'm going to show you three different chemical reactions, and they fulfill those descriptions differently. You can fill in your notes as we go, and I'll show you where you might want to write things down to understand these concepts better. The notes back here have chemical reactions, and what I've done is to illustrate them. The atoms are balls. The balls have letters on them. The letters, the element symbols. So the one that has H is hydrogen, and O is oxygen, and so on. So let's look at some example chemical reactions, and I'll just describe what you're seeing, what it corresponds to. So the first example of a type of an event that happens in a chemical reaction is where elements interact to form a compound. The example I give is this, where we have hydrogen, center screen, bonding with oxygen to make water. Also, there's a lot of energy which is released. In general, in chemical reactions, it costs energy to break bonds, like you need to break the bonds between these hydrogen atoms, but energy is released when new bonds are formed. I'd like to show you something else. Notice that the hydrogen here in this chemical reaction is not just a single ball. That there's two of them paired with each other, bonded together. The two atoms are bonded together. This is H2. That is a learning piece from Science 9, where hydrogen doesn't just go through life as single atoms. Hydrogen forms molecules where the molecules are made of pairs of hydrogen atoms. In the same way, oxygen over here is O2. This is oxygen gas. The oxygen gas that you or I breathe in is actually made of pairs of oxygen atoms bonded together. And water. You've all heard of water as H2O. You may not have thought of water, asked yourself the question, well, what does that actually look like as a chemical? And here's your answer. So here's water, and we all know that's H2O. Specifically, what's going on with that is we have two hydrogen atoms, each of them bonded by a single bond to one oxygen atom. I'd like you to notice something else that I did here. I'd like you to notice that if we count the hydrogen atoms here on this side of the reaction, these are the things that do the reacting. Count the hydrogen atoms. 1, 2, 3, and 4. Count the hydrogen atoms over here. 1, 2, and then 3 and 4. Here, I'll bring this into greater focus. There's 4 hydrogen atoms that are part of what gets made. and there's 4 hydrogen atoms that are involved in the reaction. Similarly, 2 oxygen atoms are involved in the reaction. Each water molecule has 1, so for a total of 2 oxygen atoms that form part of the product. And the product there is water. This is the reaction that you get when you take hydrogen and you burn it in the presence of oxygen. There is a release of energy. I want to walk you through another one of those examples because some of the symbols that are used for this become really important. In fact, the second example of a kind of an event that might happen in a chemical reaction, number 2 in your note set, compounds can break apart to form elements. Again, I'm just showing the reverse of the reaction. H2O, 1 hydrogen, an oxygen, and a hydrogen, all bonded by single bonds. That's water. The arrow means makes. And it makes hydrogen and oxygen. And you might think, hey, you've just told me that when you have a reaction that involves those chemicals, that there's fire and energy is released, and how could it go backwards? Well, the answer is that if energy is released when you burn the hydrogen with oxygen present, that means you have to add energy to make it go in reverse. What you might want to do that I haven't set up today is you might want to check out electrolysis on YouTube. There'll be piles of video about electrolysis of water. There is how it's spelled. Kind of like you would expect it to be, electrolysis. You can pause the video back there if you want. That's a process where you use electricity, you pass it through as an electric current through water, and you have different electrodes. One of the electrodes, I guess you could think of it as captures hydrogen gas. The other one captures oxygen gas. It's a pretty cool reaction, maybe check it out. The other reaction you're going to see that fits, in this case, part 3 of the notes, which is right here. Again, you might want to copy that into your notes, is one you've seen before and one that you use a lot in daily life. This molecule right here, carbon, with 4 hydrogens, it's also called CH4, which kind of makes sense, doesn't it, when you look at the molecule, which is what you're seeing right there. A carbon bonded to 4 hydrogen atoms. Is methane or natural gas? Here is oxygen. 2 oxygen molecules. We say they're molecules, yes, it's an element, but we say they're molecules because there's more than 1 atom present. Again, the arrow means makes. It makes what? Well, with fire being the indication that there's energy involved, it makes carbon dioxide and water. And let's count the atoms again, because this gets to be really important in your learning about chemistry. Here, these are the things that do the reacting. There's 4 hydrogen atoms here, all of them bonded to the carbon. Water is being made. 4 hydrogen atoms are in what gets made. 4 oxygen atoms, each in an O2 molecule, are in what reacts. And in what gets made, there's 2 oxygen atoms here and 1, 2 in total in the water. It adds up to 4. There's 4 oxygen atoms in what gets made. All that's happening here is you're not making new atoms. You're making new compounds out of the atoms that were already there. The other thing I'm going to show you just now that you will see later, but wouldn't be part of the notes today because I don't have a diagram space for it, is a reaction for what happens when you add a metal to an acid. The metal in question is a reactive metal. You might have seen it in Science 9. It's called magnesium. The acid is a very simple acid, a strong acid called hydrochloric acid. You're going to see some of these reactions come into play when I release hydrogen from water using magnesium. Specifically, I'm releasing hydrogen from hydrochloric acid, but This happens in an environment with water. This is the other reaction. It's what's called a single replacement reaction. Don't worry about not knowing that yet because that's lesson 2. In a single replacement reaction, here's what happens, lesson 2.2. An element and a compound react, creating a compound, a new compound, and a different pure element. There's different kinds of single replacement reactions. The one that we're looking at here involves a metal reacting with a binary compound. This is HCl, hydrochloric acid. We're making magnesium chloride, MgCl2, right? Hey, look at that. 2 chloride ions. And hydrogen's being released. And again, magnesium and hydrochloric acid react to make magnesium chloride and hydrogen gas. What I've just done for you is I mapped out the reaction. I'd like you to notice that there is 1 magnesium atom in the things that do the reacting and 1 magnesium atom in what gets made. I'd like you to notice there's 2 hydrogen atoms in what does the reacting and 2 hydrogen atoms as an H2 in what gets made. Chlorine behaves the same way. New atoms aren't being made here. The atoms that are there are just being rearranged to make new compounds. So I'm going to show you some of these reactions right here. The first I'm going to show you I need for everything else to happen, and that's the combustion of methane, burning natural gas. There's one thing I forgot to get. Wooden splint. So here's what we have for the reaction. We've got a wooden splint, hydrochloric acid, not showing up super well there, hydrochloric acid, magnesium metal strip, 100 milliliter graduated cylinder there, a small Erlenmeyer flask, a Bunsen burner, water, safety equipment, a bit of detergent, and one other thing, my striker. Oh yes. And the last thing is this. Very important piece of equipment. This is rubber stopper with a hole. Out of it, glass tubing. Connected to the glass tubing, rubber tubing, which I can then direct into a flask, or actually a beaker. Here's the reaction that is the combustion of methane. Now I'll turn off the lights for this. A bit of an underwhelming reaction, I guess, but it's got all the hallmarks of a chemical reaction. We're starting with a compound with known properties. As soon as I turn on the gas, I know that something different is in the room because gas has a tracer odor. When I strike the gas, When I ignite it, I have a flame. There's a release of energy. These are all typically what's expected to happen in any chemical reaction. And we know from other research that methane is 1 carbon with 4 hydrogens. We know that there's oxygen in the air that plants give us, and that the two of them reacting make carbon dioxide and water. So that's the first reaction that I wanted to show you. We'll get the lights back on for now. I'm going to add a bit of detergent to this water here. The detergent is not part of the reaction, but it's just a piece of equipment that's used to make the reaction more interesting. There. Perfect. I'm reacting this 0.5 moles per liter hydrochloric acid. Science 10, you don't need to know what moles per liter is, but if you're in chemistry 11, you should know what moles per liter does mean, which is also shown as a capital M. Here, I'm going to use 90 milliliters of this 0.5 molar hydrochloric acid, which will be just enough to use up all the magnesium with just a little bit left over. Magnesium will be what's called a limiting reactant. Chemistry 11, consider going forward to your Unit 7 and looking up some of these concepts of what is a limiting reactant. You don't have to know it yet, but you'll have to know it later anyways. Unit 7, Chemistry 11 is stoichiometry. Good to get familiar with even now. I'm using 90 milliliters of this. I'm topping it up with just a bit of water, just so I can have 100 milliliters of a liquid in my Erlenmeyer flask. It's a small Erlenmeyer flask, but I don't want to have a lot of space for any excess gas in here. So that's the amount I'm choosing. And there. This is my acid. I've diluted the acid with a bit of water, but just diluting it's not going to affect the reaction. The water won't be what's reacting with the magnesium. It will be the acid reacting with the magnesium. The magnesium, I'll bring it closer to the camera again. It's a shiny metal that is supplied to educational labs in the form of thin strips that are used to demonstrate chemical reactions. I'm going to use 0.50 grams of it. You've all seen that I have a weigh scale, which is pretty awesome. My daughter says it's her weigh scale. So 0.14 grams. .29 grams. I'm specifically doing 0.5 grams of this magnesium. Okay. You know what? I've got 0.51, but that's okay. You can still do this calculation and it'll work out with a very similar answer with your knowledge that it's 0.51 grams. Again, hydrochloric acid, magnesium metal strip. The reaction is, this is for you Chemistry 11, if you're listening, some of you I know will want the extra marks. Magnesium plus hydrochloric acid reacts to make magnesium chloride plus hydrogen. Science 10, you're going to need to know these kinds of reactions. What I'm going to do is I'm going to be isolating this reaction. I will put this in the Erlenmeyer flask. Then I will take this tubing here and I will put it in the beaker. The beaker that has detergent. In other words, you're going to see bubbles. And here also is where the wooden splint's going to become really useful. I wonder if I can put the camera. I won't do that. Isa, you need your glasses on. Goggles are over there. I'm going to need you to hold this in place. That's all. Thank you. I'm going to put the magnesium in. Okay.
Wow.
Holding it. This is what the reaction looks like. Everyone, look really up close. You can see a hallmark for any chemical reaction is the production of gas. Now, it's been going for long enough that the gas coming through here will be exactly what we want. Maybe I need to add a bit more detergent. Can you take one hand and put it right there? Thank you. Good. It's working. Now, you might have a hard time seeing this. I'm going to try to put there won't be any explosions here, so I'm going to try and put the computer camera here. Watching. All right, so here's where you guys are going to wish you were here. Isa, you get to do it. First, I'll show you. Did you see that?
Yeah.
So I'm going to pinch this, and I want you to get some of those bubbles on your hand. Let's do that again so everyone in YouTube land can see you. You want me to do it and you want to... How about you go get another splint? Actually, how about you hold this? I'll get the splint.
Yeah.
That and that. Very good.
Yeah.
You want to do the burning and I do the handling?
Yes.
Okay. Here, I'm going to get the top. Okay, wait.
It's really light. Again?
Maybe not such a big flame. There.
You want it smaller?
Yeah, a little flame so you don't burn my fingers.
Okay, I'll do that.
A hydrogen flame will not burn your fingers, but a flame from a wood splint, that could give you a burn. That's perfect. It's perfect.
Oh, yeah. Opening it.
In fact, you know what, Isa? How about we not do it on my hand? Okay, you just put it up to the bubbles here. The class will be able to see that better.
Whoa.
Don't burn yourself. You can dip it in the water. That's what it's for. Don't burn yourself. Just drop it in. That's better.
Oh, it still has lots of water. It's just going to burn out.
There. So science 9, 10, that is that's the POP test, classic chemistry high school demonstration. The magnesium reacting with the hydrochloric acid released hydrogen gas. We made magnesium chloride, which is in solution, which we can't see because it's a clear ionic compound. And the flame from the hydrogen burns instantly. The other thing you might have noticed about that flame is that, or might have thought about when you saw that flame, is that what's in it? Well, it's hydrogen. It's got maybe a mixture of some of the gas that was in the Erlenmeyer flask when I started. But what I did is we released hydrogen from the hydrochloric acid, and then instantly we made water out of it. You didn't see it, but that was a reaction that created water. Hydrogen and oxygen were reacting to create good old H2O.
Oh, Daddy. That's a little
New molecules of water that the universe had never seen.
Where's another splint? Where's the splint? Where's the splint, Daddy? Don't stop it.
Chemistry 11, you may be wondering why you watch this. I'm having you watch it in case you want an opportunity for extra marks, which some people like. And here is my challenge to you. The reaction, which it says up here, I'll make it more up close. Magnesium plus hydrochloric acid makes magnesium chloride and H2. In other words, we could think about those coefficients as chemical amounts. This is a big insight for you. Watch this. Because the coefficients, science 10, Mg plus 2 HCl makes MgCl2 plus H2. That 2 is extremely important. And we can use more concrete language and say 1 mole of magnesium will react with 2 moles of hydrochloric acid to create 1 mole of magnesium chloride and 1 mole of hydrogen gas. Those coefficients have a real world application. That application being that they're chemical amounts. You can think of them as chemical amounts. Now, if we use, don't burn yourself, if we use a bit of extra acid, which I did, just a bit of extra acid, I didn't want to leave behind all kinds of acid to dump down the drain, but I used just enough acid with a teeny bit left over to use up all of that magnesium. When all that reacting is done, there won't be any magnesium left, assuming that the lab had accurate reports of concentration of the HCl. My extra credit question for you is this. You saw that we used 0.51 grams. I told you that the scale said 0.51 grams of magnesium. If we assume that that was pure magnesium, not weathered in any way, with any extra compound on its coating or anything like that, if we assume it's pure magnesium, my challenge to you is to calculate what volume of hydrogen gas will be created by fully reacting that 0.51 grams of magnesium, what volume of hydrogen gas will be created by doing that reaction. And I'd like you to email me your full answer with the workup of how you solve that problem. If you can consider any kind of sources of error in your estimate, there will be a few of them, possible sources of error. That would be super good too. So again, I'm looking for you to tell me, given the fact that we're completely reacting the 0.51 grams of magnesium and creating hydrogen gas in the process, what is the volume in liters of hydrogen gas that is being produced? Send me your full answer, ideally with some sources of error. If you give me a correct answer, or even just give me correct sources of error, give me something, I'll give you extra marks, because this is a problem that is a little bit at the edge of your learning right now in Chem 11. If you'd like more information about how to solve problems like this, you might want to check out Unit 7, Stoichiometry, which in my view was kind of the core of the entire course. Whatever we get through, my highest priority is going to be to get us definitely through Unit 7, because you need that learning to go on for future chemistry courses. Again, what volume of hydrogen gas will be created? Email me your answer for extra credit in Chemistry 11. I hope you've enjoyed this video.